Alright, Titans, welcome to episode 3 of your flipped classroom in your Algebra 2 class here. A little Britney Spears to get you fired up for this section 12.2, combinations and binomial theorem. We're going to be looking at mostly just combinations in this episode. You got your goals right there, what you'll be able to do at the end of this episode, so let's just jump right into it here. In that last section, we actually learned that counting problems where order was important. It was important and we called those permutations. Well, now we're going to look at some problems where it's not important. Like say you're dealt a hand of cards and you get 5 cards. Well, the order you get them doesn't matter. That's not going to change your hand. You're still going to have 4 aces and a king. Still going to have 3 tens and 2 queens. Okay, you're still going to have the same hand no matter what order it is. And we call these combinations. Combination is unordered. Order does not matter. That's the key. Order does not matter. Okay? Well, a combination is actually a selection of R objects from a group of N objects where order is not important. That is the definition right there in a nutshell. Now, if I want to take a combination of N objects, take an R at a time. So I'm picking R from N objects. Well, the number of combinations of R objects taken from a group of N distinct objects is denoted by NCR. And we just say N choose R. We said the same thing for permutations. And we say it the same, but we note it differently. This time when order doesn't matter, we put a big C instead of a big P. And the formula is right there. N choose R equals N factorial over N minus R factorial, R factorial. And you just plug in N, you plug in R, and solve. So, let's look at one here. We've got 2 objects taken from a group of 5 objects. So what I have there is I have 5 choose R. And I'm just plugging into that formula from the last slide. On top 5 factorial over 5 minus 2 factorial times 2 factorial. Well, 5 minus 2 is really 3 factorial. So now all I have to do is plug those into what I have. 5 factorial is 5, 4, 3, 2, 1. 3 factorial is 3, 2, 1. 2 factorial is 2, 1. And now what I can do is, since I have stuff on top and bottom that are the same, I can just start canceling those out. So for example, the 3s, the 2s, the 1s, I mean they really don't count, but and I know 4 divided by 2 is 2, so all I have left on the top there is 5 times 2, on the bottom 1. 5 times 2 is 10. 10 ends up being my actual answer, just by crossing those out using that formula. Okay? Moving on. Now let's find some more combinations. Let's look here. In a standard deck of 52 cards, there are 4 suits with 13 of each suit. So you've got 4 suits. You've got your diamonds, your hearts, your clubs, and your spades. Each one of those has 13 for a total of 52 cards. You've got your ace through king in each suit. If the order isn't important, how many different 5-card hands are possible? So how many different hands could I get if they just handed out 5 cards to everyone? Well, the number of ways to draw 5 cards from 52. That would be 52 choose 5. So on top, 52 factorial. On bottom, 52 minus 5 factorial times 5 factorial. And going through this one, kind of the same deal. 52 factorial is 52 times 51 times 50, 49, 48, 47. Then it'd be everything smaller than 47, which is just 47 factorial. Well, on the bottom, 52 minus 5 is 47 factorial. I can just cancel those out. So I didn't actually have to write all of them out there. Okay, so all I have on top is those 5 numbers. On bottom, 5 factorial. Multiply out, divide, and you actually come up with 2,598,960. Use that calculator and multiply those out and divide by 5 factorial there. Make it a little simpler. Okay? Nice little deal there. Let's keep going here. How many 7-card hands are possible from a deck of cards? So now we're looking at just a 7-card hand instead of 5. Well, I've still got 52 cards. So I have 52 choose 7 here. On top goes 52 factorial. On bottom, 52 minus 7, which is 45 factorial, times the second number factorial, which is 7 factorial. Go ahead and multiply those out, divide, you end up with 133,784,560. Now what I'm going to do is I'm going to show you my shortcut method. That's a little long, a little confusing for me sometimes. So my shortcut method is when I have 52 choose 7, I'm just going to do that. Turns out it's just 52 permutation 7 on top, and on bottom it's that second number factorial. So I rewrite the top with permutation this time, the bottom 7 factorial. So I write that. Again, how to do 52 permutation 7, make 7 spots. Start at 52, work my way down. On the bottom, 7 factorial, 7, 6, 5, 4, 3, 2, 1. I could go through, start canceling these out like 749, that's just 7, and keep going there. But if I just multiply the tops divided by what's on the bottom, I would actually come out with the exact same answer. So that's kind of my shortcut method. Just do permutations on top divided by the second number factorial. Or you could use the other formula. Your choice. And your choice here on these next ones. So go ahead, pause the screen for a little bit here. See if you can solve these two combination problems. Alright, hopefully you pause. Now you're back, ready to look, see what these are. Well, 7 choose 3. I'm going to do the shortcut method here. On the top, that leaves me 3 spots. 7, 6, and 5. On the bottom, second number factorial, so 3 factorial is 3, 2, 1. 3 times 2 is 6. I cancel those out. All I'm left with on top is 7 times 5, which is 35. Not too bad if the numbers aren't big. Second one, 9 choose 4. Again, my shortcut method. I got 4 spots on top. Start at 9, 9, 8, 7, 6. On bottom, second number factorial, 4, 3, 2, 1. Cancel out what I know. 4 times 2 is 8. 3 and 9, and that leaves me with a 3 right there. On top, 7 times 6. On bottom, 3 factorial there. Or sorry, 7 times 6 times 3 on top. 7 times 6 is 42. 42 times 3 is 126. And there are my answers right there. My shortcut method. Hopefully if you did it the other way, you still came up with the same answers. Alright, moving on, something a little different. Now we're going to decide kind of the plus or times here, and we're going to have a rule for that, but let's look at this example. A restaurant serves omelets. They offer 6 vegetarian ingredients and 4 meat ingredients. And what I want is I want exactly 4 vegetarian ingredients and 1 meat ingredient on my omelet. So how many kinds of omelets can I order? How many possible ones are there? Well, how I solve that is I'm going to take my first one, which is vegetarian, and I only want to choose 2 of those. So I'm going to have 6 choose 2. The next one I'm going to do is I'm going to do my meat, which is 4 choose 1. And what I will do with those is I am going to multiply those together. And it will give me my total number that I want. So you're going to multiply those. Well, 6 times 2, 6 choose 2, 2 spots, 6, 5 over 2 factorial, times 4 choose 1, 1 spot, 4 over 1 factorial. Turns out that's just 15 times 4, and 15 times 4 is 60. So there are 60 possible combinations of omelets I could have with 2 vegetarian ingredients and 1 meat ingredient. Now, how did I know to multiply that? Well, we'll talk more about this in class, but the key is that when there's the and in between, so the word has and in it, event A and event B, then you multiply them together. Now, if you have the word or in between, then you're going to add them together. Okay, so and or. They're kind of our key there. Alright? So here we go. Last problem. Suppose you can afford at most 3 ingredients. So all I want is at most 3 ingredients. How many different types can I order? Well, I can order an omelet with 0, or 1, or 2, or 3. And let's say there's 10 items to choose from. This is just a different problem. There's 10 items to choose from, and I want at most 3. Well, at most means that's the very most. I could get 0, 1, 2, or 3. That or word tells me I am going to add. So I'm going to have 10 choose 0, 10 choose 1, 10 choose 2, and 10 choose 3. And I'm going to add those all together. Well, 10 choose 0 is just 1, 10 choose 1 is 2, 10 choose 2 is 45, 10 choose 3 is 120. Hopefully you can go through, find those out, make sure those numbers are right. And all you do is add those all together, and I get 176. So at most means that's the very most I want. I can get all those numbers below though. It's an or statement, so I add. Alright, that is pretty much it. These counting problems that involve at least or at most are a little tricky. They're the trickiest problems. They really make you think. We'll look more of these in class tomorrow. Hopefully you enjoyed episode 3. Ready to rock and roll in class.